Thursday morning. Everybody's awake? Kind of, sort of. We're always awake enough to hear about static analysis too, right? Because this is such an exciting subject to talk about. Hopefully you will find this interesting. This has been a fun project for me to work on because I come from a development background, and I'll get into kind of who I am, what I do. I am an instructor with the SANS Institute, so I teach a number of courses in the AppSec curriculum space. I author the Secure Coding in .NET class, our mobile application security class. I also teach the Java Secure Coding class, and we have a Secure DevOps course that kind of goes through a lot of integrating security into the CI pipeline and how to do DevOps securely, which is kind of how the talk today is going to tie into security, building it in from the beginning. So when I'm not teaching for SANS, I do that roughly 50% of the year. SANS is kind of unique. All of the SANS instructors, or almost all of them, do not actually work for SANS. We are practitioners that just spend 10 to 12 weeks a year teaching courses. So when I'm not teaching or doing training, I have a small consultancy called Cypress Data Defense, where I am just a security consultant, and I do static code analysis, web app, mobile pen testing. Most of my work over the last, I'm going to say, year or so has been all in secure SDLC management. Everybody wants to have this beautiful, continuous DevOps pipeline, and that's the perfect world, right? Except that has anyone actually tried to do that? Lots of people are smiling. We all know it doesn't quite work how it's all written out to be. So it takes a lot of work. So I spend quite a bit of time helping organizations wire security into those DevOps pipelines as well. Tools development, I have to admit, so I got out of college and I did web development for a fair amount of time with a big financial institution in the US. And I got to write code every day. And of course, has anyone been a developer full-time? Anybody still a developer full-time? You all will probably relate with this. When you write code long enough and you get involved in projects long enough, then you start supporting them, and then you start becoming more of the manager of the application. And then you actually hit a point where you don't really write code anymore. Has anyone gone down that path? A couple hands. You know what I'm talking about. So that's the path I went down, except I started going down into the security space at that point. I started writing centralized components for these web apps, and then flipped over and started doing all static analysis on internet-facing apps, vendor apps, all of those sorts of things. So this project, what I'm going to talk about today, is actually pretty fun for me because the .NET framework was kind of where I started in the development world. So it's kind of fun to circle back, 15, 20 years later and write a security tool that hopefully you all will find very useful to use. Plus, I got to write code again. You can only do so much pen testing and write up so many pen test reports before it kind of gets monotonous. So this has been exciting. So here's the roadmap for today, what we'll talk about. I will introduce you to the current .NET static analysis options that we've got available right now. And I will prove to you that they are limited with their quality, we'll say. And when I talk about these static analysis options, keep in mind, I'm not talking about commercial. I'm talking about the poor man's approach, where we're going to walk in and try to use some free and open source utilities. So that's where we're focused. I will introduce you to the Roslyn API, which is a new open source compiler that has been out for about a year now. So you'll get to see what that is, how it works. I'll teach you how to write a code analyzer using the Roslyn APIs to actually locate something bad in some source code. I will teach you how to do some additional file analysis in a non-code file, such as a web config file or maybe a JavaScript file, something of that nature. I will introduce you to a new tool that we released last week called the Puma Scanner, which is a free tool that does a lot of the things that I'm going to teach you how to do. And then I'll talk to you about some future enhancements that we're going to make to it. Sound exciting? All right, let's get started. So what are our options right now? I teach the .NET class for SANS, and inevitably throughout every class, somebody asks me, well, I don't have the money in my budget to go purchase, an expensive commercial static analyzer. So what can I use? And the options are always very limited. So I tell them, well, you can use cat.net, you can use FXCop, and that's really all that we've got right now. There's also Visual Studio Code Analysis, which I'll mention here in a moment. And then there are a couple of web.config analyzers for the old school web forms apps that will look at a configuration file and identify some potential issues in that file. Troy Hunt wrote one, James Jardine wrote one, and they are not integrated really at all in anything. It's a separate executable that you have to go run outside of your dev lifecycle, which, of course, as we know, ultimately those results don't usually end up back in the hands of the actual developer that needs the results. They end up on some security person's desk, and they sit there and collect dust, and we lose track of it. So these options are limited for several reasons. We'll talk through these pretty quick. Before I do that, I wanted to tell you about the target app that I'm using. So Widgettown is an app that was originally written by Louis Gardenia for the SANS Dev 544 class. I've been owning this app for probably the last 6 years. I built out an equivalent MVC app. So this app has a web forms and an MVC app. It's got over 50 different vulnerabilities in it, and it's just a mock e-commerce style application that's chock full of problems. So when I'm evaluating these tools, this is the code base I ran it against. So I know where all the issues are in it, and I'm going to benchmark them, these different scanners, against this application. So let's do a mini code review real quick. I bet you all woke up this morning and thought, gosh, I hope at 9:30 I get to review some crappy code today. Anybody? Yes, perfect. To the rest of you, you get to do it anyway. So the first one is an account controller. This is auto-generated by the identity framework in .NET. We have this login method, and there's a comment that's auto-generated by Visual Studio that says, this doesn't count login failures towards account lockout. And we have this should lockout parameter set to false. Does that sound bad to anybody? Right, so we have no account lockout on this particular login form. So that's an issue we'll take a peek at. Let's flip the file here. We have a contest controller with an action called download that takes a file name as a request parameter. And then it conveniently adds that into the file path right here. So what could we do with that? There's nothing wrong with that, is there? Maybe a .. attack, perhaps? Path tampering, path manipulation, pretty basic stuff. Here's a REST client that's called from the front end that has this comment that says, disable certificate validation for the dev and test environments that just returns true during the certificate validation handler. So we're disabling certificate validation. Another issue we should probably flag in a scan. Another controller here that has our old friend string q equals delete from contest where ID equals some value, and then we pass that directly into an execute SQL command. Everybody knows what that one is, right? I'm hoping. Everyone nods yes. It's been on the OWASP top 10 #1 for 10 years, so hopefully we're all aware of this one. Another login page. This is on the web form side where we take this return URL from the login form and then we do a response redirect to this location. Again, OWASP top 10 item. That should probably be flagged for an unvalidated redirect. And we could keep going. We could take the whole hour and just pick this app apart, but I'll show you just one more. And we will then load up the rules and we'll look at this code again at the very end and see some very interesting diagnostics raised from within the IDE. The last one, we're reading a product name out of the database and we're setting it directly to a label in the browser without doing any sort of encoding. So we've hit over half of the OWASP top 10 with these very quick code snippets. Everyone agrees we probably have some issues that need to be addressed here, right? So let's scan this code with our current free and open .NET scanning options and see how we do. How do you think they're going to do? Any guesses off the top of your head? Good or bad? Hold up the green or the red card. No one has the cards. Okay. Cat.NET was released in April of 2009. And I thought when it came out, and I remember Jeremy just walked in, he worked with me in a former position, and I remember we talked about this and said, well, let's scan some .NET code with this and see if it actually finds anything useful. And we scanned a couple of apps and we quickly determined No, it did not really find anything useful. So I had very little faith that this was going to find much. Version 2.0 got to a beta phase, and then Microsoft pulled the funding for it, and it never even got out of the beta phase. So it died pretty quickly. The link to download it's there if you would like to go play with it, though. So let's run this against WidgetTown. I ran this yesterday afternoon on the latest version of the code base. I've got it analyzing our 5 different projects. And you can see in the PowerShell output there, it found 1 unvalidated redirect issue and 2 cross-site scripting issues. So it's not worthless. It found a couple of things. I wouldn't call it good. And I did verify both of those are actually true positives. They're valid, or all 3 of them are actual issues. Okay, so we've got 3 findings. Let's run FXCop, which is more of a style checking tool. It does, design, naming performance, globalization, those types of things, that conformance issues that we would look for, but it also does have a couple of basic security rules, primarily for SQL injection and cross-site scripting. Now, what Microsoft did in Visual Studio 2012 is they wrapped FXCop up in this new option in Visual Studio called VS Code Analysis. So you can go in and right-click on a solution and say, analyze my code, and it will kick off some security rules for you. So when I first saw that, I thought, oh, cool, maybe they built in some really good rules, and we can just start running this during our build phase. You pick the Microsoft security rule set, and you just say, analyze the solution. You can create custom rules, but I would say good luck to you if you're going to try to do that. I tried. They're not well documented. The way I will show you in the next section is much, much easier. So just skip that part. So I ran this against WidgetTown, and I found 2 more issues. And you'll notice at the top it's complaining about strong name keys on all the DLLs, which just ignore those. That's a waste of time, at least from a security perspective. But we do have 2 valid, well, not valid, 2 SQL injection instances identified. One of them is a true positive, one of them is a false positive. So I ran our 2 options for .NET right now that are free and easily available, and here's what we got. 2 cross-site scripting, 1 SQL injection with 1 false positive and 1 unvalidated redirect. Green card or red card? I showed you the code. I showed you some of the instances in here. How do you think? I got a red. Does anyone think this is good enough? No? It's a trick question. Don't say yes. Okay, so we'll go ahead and tag this with the fail stamp here. No good. We have to do better here. The next section, the Roslyn API. Has everybody heard of Roslyn? Anyone not heard of Roslyn? So some yes, some no. This thing is awesome. So what Microsoft did, which the revolution is pretty cool what's going on over there, we are now basically getting all of the code that we've been running in the framework for years is now in GitHub. They're open sourcing everything. And what they did is actually open sourced their compiler APIs. Now we can call them. So lots of people are currently writing Roslyn plugins. They're rewriting ReSharper most likely to work with Roslyn so you can get these squiggles in the code base. So if you look at the slide, it's kind of hard to see. Let me maybe zoom in on it here and I'll see if I can. Does everybody see the little squiggle under that false there? So you can identify locations in code that have problems and get these squiggles, and you can give them suggestions on how to fix them. These show up as compiler warnings, so it's all nicely, tightly coupled into the IDE now. And people are using this for style checking and all sorts of neat little features on how to force developers to put curly braces around stuff and all of these normal usage scenarios. And I saw this and I thought to myself, what if we wrapped security rules around Roslyn and we were able to give this feedback to a developer immediately as soon as they do something not so good as they're writing code? That would be interesting, right? So back in May, I started this project, started poking around with it, trying to figure out how in the world this thing worked. And this is where I started. So if you're going to take this home and you want to just jump in and start pulling things down, you need Visual Studio 2015. You also need to download the Roslyn SDK, which is a Visual Studio plugin. And the steps are described in this MSDN magazine article. The link is on the slide. I will post these slides on the SANS blog at some point next week, so you can pull them down from there. Don't worry about, I see some of you taking pictures, which is fine, but don't try to jot it down in a hurry. So that's the first step. The next step, once you download the Roslyn SDK, you open Visual Studio, you go File, New Project, and you can pick from an extensibility template called Analyzer with Code Fix. And it will generate 3 projects for you that you can then start adding rule sets into. So it's very simple. And I'll show you this here in a minute. The next important thing you need to add is the actual syntax visualizer, which is in the .NET Compiler Platform SDK. This thing does all of the work for you. You don't have to actually understand what a syntax node is called and what class represents it. You just use this visualizer and it parses the entire body of a code document for you and tells you exactly what everything is. So let's take a quick look at this. I've got this analyzer that I called My Awesome Analyzer, and I just went through those steps. I did File, New Analyzer, and this is what I landed on. So I've got this code here. We will walk through this so you can understand the 2 sample analyzers that I put in here. And the first rule that we're going to create, this demo 1 rule, is we are going to identify a weak password length in identity. So right now, out of the box, you generate a new solution and you say, I want to use identity as my auth provider. It will give you a password complexity with a minimum length of 6 by default, which is pretty crappy. So we will find that and we will flag that in the code. So to do this, we're going to use the syntax visualizer. So here's the syntax tree, and let's take a look in our MVC app, and we have this identity config file, and let me expand this just a shade so you can see what I'm looking for here. So we have this, let me minimize this guy. Wow, hang on a sec. My windows are getting all sorts of out of whack here. All right. So we have this password validator line right here. We're saying manager.password validator equals new password validator, and then we have this required length of 6. So that's the code that we would like to analyze. We want to find this in the code base and flag it as something bad. So when you pick password validator, so I've just highlighted that, you'll notice the syntax visualizer over on the right. So let me zoom in on this so you can actually see it. Is actually telling me you just highlighted this object creation expression. And the type is an object creation expression syntax. So it just told me exactly what I need to look for. And then if you go down into the properties, you can see we have a value on this called initializer, which contains all of those initialization expressions. So you can go back up and grab the identifier, which is an identifier name syntax, and see here, let me find our token. So there's an identifier token, and that is also part of password validator. So essentially, we are going to find this simple assignment expression. So I just double-clicked required length equals 6. Let's go find it. And it says that is an assignment expression syntax. So right now we know that we need to grab the object creation syntax, grab all of the initializers, and search for the simple assignment expression with a name set to required length. So it's about 4 checks that we need to do to build out an analyzer that actually can flag this. Sounds pretty easy, right? And this thing does all of the work for you. You don't have to know anything about compiler tricks or any of that stuff to do this. So let's take a look at what that code can actually look like. So we'll walk through this. And I'll forewarn you, there's lots of code on the upcoming slides, so brace yourself. This is exciting stuff. All right. So the 4 things you need to understand to write a rule. So this is my code analyzer 101 section. you need to use a diagnostic analyzer class. You need to know what a descriptor is, the analysis context, and a syntax kind. 4 things you have to understand in order to write a rule. So let's do this. The diagnostic analyzer class. So on the slide, can you guys read that in the back? You want to zoom in on it a little bit? I saw a thumbs up. So line 1, we are using the diagnostic analyzer, annotation, or attribute, whatever you want to call it. We're saying let's target C#. So this will run on C# classes. And then we inherit from the diagnostic analyzer base class. And of course, I named mine my awesome analyzer, just like that's in the code that I'll show you here in a second. So step 1, we create the rule. Step 2, you have to actually create a diagnostic descriptor, which describes this rule that you want to create. You give it an ID, a title, a message format, and a description that describe what is going to be displayed to the user as they type in something potentially insecure. After you do that, you have to add that rule to the list of supported diagnostics for this particular rule set. So this can have more than one diagnostic raised out of an individual rule. Pretty simple so far, right? Okay. Step 2, we need to actually determine what to look for. So this gets a little interesting. There are lots of options. So you have to determine a callback method that you would like to put your code into. So you have options for looking at a code block, which will fire when an individual code block, such as an if block or an else block or a switch block, is actually parsed. You can do a compilation action, which will fire just when compiles actually occur. You can do the semantic model action, which is at the parsing of an entire semantic document. You can get a symbol action, which is when every single symbol is analyzed by the compiler, it fires your method. Or you can analyze a syntax node or a syntax tree. So there's lots of options here. This was the hardest part for me to figure out, which one of these do I actually need to use. And from most of my rules are looking at either a symbol or a syntax node. So those are what I've been using heavily so far. And we will look at a symbol here in a minute. So when you use one of those methods, you have to choose what symbol or syntax you actually care about. It's not going to send you all of them. So if you pick a syntax analyzer, you can pick, would you like to be notified when it encounters a method declaration or an object creation expression? Does anyone remember what our password validator was? The object creation expression. So that's what we will use in a moment. You can also do an invocation, which is where we actually invoke a method such as execute SQL. You can do a simple assignment expression, which is where a variable is assigned a value. On the symbol side, you can get a list of all the parameters or all of the methods or fields or events or any of those things. So this enumeration list is much larger than what I have on the slide. So you can go out and look in their code and get all, I think there's a couple hundred options. But primarily, these are the 8 that I have used so far to build out all of the rules that we worked on. So our password length analyzer, let's actually implement this and flag required length of 6 as bad. Sounds pretty easy. So let's take a peek at this. The first thing we do is we override initialize and we pick that method. So we're going to say register syntax node action. We give it the method we want to have invoked when it encounters a syntax kind of object creation expression, which is what that tree visualizer told me the password validator class was when we actually stood that thing up. So this will fire every time it encounters an object creation expression. And it is up to us to actually filter them down to the one, as on line 5, we grab our object creation expression. And then on line 7, we're going to say, if the type is a password validator type, we'll keep going. Otherwise, we bail out. If the type matches, we will then grab the symbol and check its namespace, because it's possible that maybe somebody wrote a different password validator class that's completely unrelated to what we're working on. So we'll actually make sure it's in the Microsoft.asp.NET identity namespace. So now we know we are getting a object creation expression of Microsoft.asp.net.identity.password-validator object. So we know we are in the right spot. All we simply do now is grab those initializer expressions that were those lists of properties being set, and we can simply loop through them until we find the one that has a left, which is the left side of the expression, equal to required length. And then we can grab its value. So now we have whatever that number is that the property was set to, which in this case was 6. We do a simple compare. If the min length is less than 12, which that's just a floating number I threw in there. Obviously, hard coding that is not a good thing. And unfortunately, right now, the rules that I wrote have 12 hard coded in there because I haven't gotten far enough. Eventually, I want to pull that out, into like a little JSON config file so everyone using it can configure their own complexity and timeout rules and all that fun stuff and have it run as their policies are set to, but I'm not quite there yet. For now, we'll go with 12. So once we identify that it is a weak length, we can then raise the diagnostic. So we create the rule, and on line 41, we're passing in a statement.getLocation. So we're saying create a diagnostic with this rule metadata, the ID, the description, the title that we defined, and plant it at that location in the source code. And then we simply say context.report the diagnostic, and the IDE will take care of all of the rest for us. How simple is that? So in about 34 lines of code, we just created a static analyzer rule that underlines the password validator expression with our squiggles and says required length of 6 is not good. You can do better. It's so easy. So all I have to do is just build these things out. So that's an example of a code analyzer rule. Now this code I have actually put in my GitHub repo, and I'll give you the link to it in a minute. So the sample password validator analyzer is out there, this project here. So once you write your rule, this code is exactly what I just showed you in the slides. So we're not going to walk through it again, but what I'll show you is to test your rules out, you can simply just fire this thing up. So you hit the start button, and your extension will actually launch a debug instance of Visual Studio. So you're now in the debugger with the actual My Awesome Analyzer extension installed. It will run the rules for you, and then you can open up your target. So I've got this demo target app, which is basically just a file new MVC web app with identity turned on, is all I did. And we should see a diagnostic warning raised when the actual code executes. And you can check to make sure it's working. If you go to Tools and Extensions, and you scroll down the list, and I'm in the M's, you can see here, My Awesome Analyzer is a registered Visual Studio extension in this debug instance. So that's all you have to do to get analysis, at least at the IDE level. I'll show you the way to do it in NuGet here in a minute. So at this point, let me take a look at my error list, which of course there are none. And now, I open the actual code document, and did you see the warnings pop in there? So we parsed the actual code syntax, .NET did its thing, Roslyn's running, and we have underlines on that particular code snippet. New password validator, you hover over it, and it says, the ASP.NET Identity Password Validator does not meet the minimum length of 12 characters. It's telling the development team right out of the gate, as soon as they write that code, you have made a mistake that does not meet our security policy. And we can come in here and change this from a 6 to a 12, or let's just go with 15, and guess what goes away? As you're writing code, these are constantly running and updating in the background. So I'll get to CI in a little bit. MS Build, if you run it out of the box, will run the analyzers that are registered with NuGet. So you can run this out of band and get that data without actually needing to open the IDE and run those syntax rules. Make sense? Because it's just, that's the beauty of this whole thing. It's wired right into the build environment. The actual IDE is the one that's running the same build steps. We're just adding more checks to the compiler as we go. So I'll talk about that other rule that's in there here in a minute. So let me back off of this for a sec. Code analyzers are good, but we have lots of other areas and applications that need some love too. So what about non-code files? This is where I ran into my biggest hiccup. Security issues commonly exist in config files, .json files, JavaScript files. We have lots of view markups that can have raw writes out to the screen on the cross-site scripting side. We have external JavaScript references. In even non-compiled languages, Visual Studio, especially VS Code on OS X, for example, now has Ruby, Python support. You can write all of that code within Visual Studio, and it'd be kind of cool if we could run diagnostic rules against that stuff too, right? At least I thought it would be, but I'm weird. So I sat down and I said, how can I do this? And it turns out that Roslyn out of the box doesn't really support this. So where some people may give up, I am a hacker by nature, and I said, well, there's got to be a way to make this work, right? I'm not going to give up that easily. So I looked into the compilation action, and I get this object called additional files, which are these other files, non-code files. Now, what these were intended to be is, remember I mentioned it'd be cool if I had a JSON file that let you set your own password rules and some of those things, your session timeout values. They're supposed to feed data into an analyzer, configurable data. But I can also look at config files and JS files in this additional file list. So I've got access to the info within this compile action. Step one, now I have the files, sort of. I'll show you what I ran into. But the next step is, after analysis, I actually need to add a diagnostic warning to the additional file. That was the biggest hiccup. Visual Studio doesn't officially support this. The best part about this being open source is that I went on to GitHub and I found 3 guys that had made recent commits to the Roslyn API, and of their email address at Microsoft is on there, and I emailed them and I said, hey, this is what I'm trying to do. They pointed me to this Git issue. I added some comments. So there are some conversations going on between me and a couple of the guys within the Roslyn team. They understand what I'm trying to achieve, and there's an open Git issue for this at the moment to get the full IDE support of this. Of course, it's a feature request. It has not been implemented yet. But they also gave me some workarounds and said, I think we can make this actually work for what you're trying to do. It won't be perfect, it won't be pretty, but you can at least get a compiler warning for it. So here's what I needed to do. Number one, the additional files are not automatically loaded into that list, that property I just showed you. We have to tell the analyzer to go look for them. So that was step one. And two, this cost me hours of debug time. If I actually, do you remember that statement.get location I passed to the rule in the last example? If you set that value on an additional file, the IDE just swallows it and it disappears. I don't know why. So I kept adding these rules and they were never showing up, and it drove me absolutely insane until one evening, probably at midnight or 1 in the morning, I just deleted that and then the rule showed up. I can't tell you why. So that's another issue they're hoping to fix with that bug. So step one, getting the additional files to show up. We have to actually edit the .csproj file and add this little property group snippet to the csproj file. So I'm telling the csproj file, all of the additional files, if it's tagged with the content property in Visual Studio, load them all into the additional files list. And this is in the install instructions in the tool that I'll show you. It tells you exactly what to do. I'm hoping to have my NuGet package eventually automatically do this for you when you install the NuGet package, but it's not there yet. So for now, you'll have to make this little tweak to the file. Then, the whole source location problem. If I give you a diagnostic and I don't tell you where it is or what's the problem in the code, it's not very useful, is it? Some of them are tagged with deploy. So there are 4 or 5 options in that dropdown. So if you take a look at any file in Visual Studio. So if we just look at the properties for this guy, it's set to, let's see, let me find, yeah, build action, compile. So compile is your source code, your CS file. And then you've got content, embedded resource. There's the additional file option where you can actually set it to that. So you have to basically just go in there and tell it which files you would like to be treated as additional files. So content typically is what all of the config files and all of the view markup files and everything are by default. So you need to double check that. If it's not showing up, go check what that value is set to and you can add that to that list. Good question. Okay. So the next step is actually getting the line number and the offending line into the rule. And what I did is I used the message format. Just like any other message format, you can pass parameters to this thing. So instead of setting the source location, which makes it go away, we can actually say, hey, debug compilation is enabled, and we can pass the 0, 1, 2 there and actually pass in the file path, the line number, and the offending line of code in the file. So at least it displays in the warning, so the user knows what the heck we're talking about. And then we can say context.report diagnostic and do the rule, and then pass in, remember, use location none because that's the bug. And then you can pass in your path, line number, and line as 3 parameters after that, and it will fill it in for you. So that right now is my workaround on at least reporting diagnostics in some of these non-code files. And this is what they will look like. They will be right there in line with the rest of the diagnostics raised from your .cs files. Except you can't double click on them, which is super annoying, and that's also in that Git issue. But at least you can see them, you can make them go away, and they will show up in your CI scans as warnings, so you can find them that way. So I'd say we're halfway home at this point with these, but at least we could do something with them. So going back to the running instance, if you take a peek at this other item, the debug compilation is enabled, message is showing up. That is from the diagnostic rule I just mentioned. So if I take a peek back in my awesome analyzer class, you can see that code. So here's the demo 2 diagnostic, and it's saying debug build is enabled. And essentially all you have to do is grab this additional file list. We're going to filter it down to .config files, because this one just is looking at configuration files. And you just do some XML parsing. It's pretty simple. Load the XML. Let's look for the compilation element. Check the debug attribute. If it's set to true, here's the diagnostic.create that's causing that warning to show up. Same concept, it's just in a different analysis context. So if we come back to our demo target with that rule, let's open our web.config file. Let's find our debug equals true statement. We can set that to false and hit save. Now remember, this runs at compile time, so this is not as immediate as the code changes. It'll take a few seconds for it to go away because the IDE is running compiles kind of in the background periodically. So you may not get the real time, but it will go away. Just while I was speaking, you can see that drop off. So those are 2 different analyzers that you can use to build out security rules within your apps. Pretty awesome, right? Okay, so I gave you 2 rules. I showed you how to create a normal code rule and then a non-code rule. I talked about these limitations already, so just recap. They're not automatically loading additional files. You need to edit your CSproj files to add that content option. And I will get the ticket eventually worked through on my side for the tool I'll show you in a minute to have NuGet do that for you. You have to manually edit your project files if you're going to use the VIX extension install option. So there's 2 ways to get these into the IDE. Double-click navigation is not supported. It's hard. I double-click on them still, expecting it to take me into the file. It won't do it. And you unfortunately don't get the nice little spell check squiggles inside your config and your non-code files yet. That's part of that Git issue I talked about. So all of the code that I mentioned up to this point, those 2 examples and that target are in a Git repo that you can go download. So you can pull all the code from the discussion down up to this point, and you can tinker with those. So that's out there for you to play with. Again, I'll publish these slides on the SANS blog at some point next week. If I don't, because I suck at blogging, ping me on Twitter or something and remind me to do it. So, at this point, you know how to write the rules yourself, so we could end the talk and I could tell you to go do the work all by yourself. But that wouldn't be very exciting. So, I will introduce you to what we've been calling the Puma Scan. This is a free Roslyn secure code scanning extension. It's out in NuGet and the VS Marketplace. Right now, I'm sitting at about 40 rules so far that I've written in version 1.0 that you can download and you can install right now. So let's do that. We've got about 15 minutes left, so let's tinker with the Widgettown project. Let me close off this demo target and kill off my awesome analyzer. And now we are left with the Widgettown code that we kind of made fun of in the very beginning of the talk. So let's go ahead and install the Puma Scan extension here. So if I view my package manager, let me grab the console, and let me clear this out. I'll zoom in on it so you can see it. So here's all we're going to run. This, if you're not familiar with NuGet in Visual Studio, this is essentially just a Maven add. We'll do an install package, puma.security.rules. That's the name of the NuGet package that's sitting out there. So we can run this, hit go. It will go ahead and pull it down. It's a pretty lightweight package. So I've got it installed in at least the web forms version now. So at this point, let me go ahead and open the package manager for the entire solution. I'm too lazy to run that command 4 more times on different projects, so I'm just going to do them all at once. So we can see that the NuGet package is now associated with the solution. We'll come over here and actually check all projects. So I want to put it on all of these things and hit install. Oh yeah, if I have to accept my own license terms, I'm good with that. I don't know what's in there. And that's all it takes. So the tool's installed. So we should be getting the nice squiggles and diagnostic warnings at this point. Let me kill this output window and find my error list. Here it is. So before I had 0, now I'm sitting on the order of 64 different warnings that have been raised from the Roslyn rules that are now running on all of these projects. Remember what we got with our free and open products in the beginning. Does anyone remember how many there were? 4 or 5, something like that. So now we've got 64, and they range from custom errors are disabled. We're missing secure on our forms auth cookie. Those are on the old web forms side. Your HTTP response header is showing, right? The one that tells you the .NET version and runtime that you're actually using. Event validation's off. View state Mac is off. So there's all the config rules running. Your machine keys in, clear text in the config file. Then we get into some of the code warnings. Your password lockout is disabled. Your length is not quite right. Missing a ton of anti-forgery tokens on the MVC side. We've got a massive amount of raw writes out to the screen and a whole bunch of views. All sorts of good information coming back. So we can come into the actual files. Let's walk through these. So here is our weak password validation. We can change that to maybe 15, and this is actually looking for more. It wants you to actually go in and say require a digit is true. You know, it's trying to get you to actually add complexity to it is true. And you can start adding those types of things to this rule. And eventually, once I get through them all and save it, so now we have a 15 length, we require all the different character types, and guess what's gone away? Squiggles are gone. How about our REST client? Now this is the easiest one we could possibly fix. You disabled cert validation. It's telling you about it. Just comment that out. We'll get rid of that because that was for dev anyway. Our contest controller, the old SQL I issue. So luckily for us, we can just say string q equals and just say delete from contest where ID equals this. So let's just leave the placeholder like that. And then we can come in here and actually just pass ID as a parameter in the second argument, like EF wanted us to originally. That diagnostic goes away. On the web form side, here's a cross-site scripting issue where we're actually flagging a couple of database writes out to labels and literals. we can simply do something like the anti-XSS encoder .html encode. Drop this in here. That diagnostic warning goes away. Writing secure code is so easy now. We'll go to our contest controller. This was the whole file name download, right? So in this case, maybe we just change this to an integer. We know we can't put a // in an integer. That one goes away. And as you're typing out your code, everything is starting to drop off of that list as you make your changes. So we're down to 60 warnings now. Now, I won't spend the next 10 minutes teaching you all how to fix .NET code. I'll just assume that you all know how to do that, right? We're all good. The warnings are there for you. They tell you what to do. Another cool thing about this is once you get the diagnostic warning, I will tell you I spent more time documenting what in the world these things mean than I did actually writing the rules themselves. So you get a link here. It says get help for this diagnostic warning, and it will actually link off to the PumaScan site and take you straight into the actual issue that it's telling you about. So it says you have a clear text machine key in your web config. That's bad. Use ASP.NET Reg IIS to fix this. And then you can come over to the site, and it actually says secrets are stored, not encrypted. And then it says, by the way, here's the secure way to do it right next to it. And it gives you the Reg IIS command to actually encrypt that section of your machine key file, or of your web.config file. It tells you what to do just by clicking on the link. That's as good as I can do to help get secure .NET code into the world. At least to this point. We can add more rules. Go ahead.
So I know that you created rules specifically, the use case in mind, right?
Yep.
That applies to other projects, but comparing to a commercial scanner, have you been able to do a comparison with this?
Yeah, so the question is, have I done a comparison between this and some of the commercial options that are out there? I have access to 2 commercial scanners that I unfortunately am not allowed to mention publicly which ones we're using. They're still more advanced than this at the moment, so there are some limitations.
Yeah, that's what important. Yeah, they have 10 years of R&D for the
Right.
R&D and budget that you've done it on a few times. So, but the comparison itself.
What I can tell you, the rules that I'm writing are very much based on what I know come out of commercial scanners. Now, am I going to find everything they do from a data flow perspective? Not right now. Eventually, maybe we'll get there. But it will knock out, I'm going to throw a percentage at you just off the top of my head. Probably 70% of the things that they find, we can knock out with this simple free utility.
And it's not a lot.
Currently not. I just released this last week. It's like fresh off of the press here. So I don't know what the direction will be. It will always be a free extension. I can tell you that much. Just because I'm going to use it in my Sans Dev 544.NET class. I'm going to make the students write 4 or 5 of these rules, and then I'll show them that I did all the work for them after they struggle through that exercise. So there will always be a free version. So here's the stats. So what I found in Widgettown with this rule set, I've got 64 issues that showed up. I went through all of them. 10 of them are false positives. There are limitations to this. So right now, right, I'm looking at strings. There's not much of a data flow contextual analysis available here. So I can't go back and tell you whether a value is coming from a request parameter or whether it's coming from a static config file on the box. It's not smart enough to do that yet. It does filter out down to at least strings. So it won't flag ints or decimals or any of that stuff as a cross-site scripting issue. So that is Eric doesn't have enough time limitation so far. There is a data flow option on a symbol. You can on a symbol call get data flow, and it is supposed to tell you all of the reads inside and outside of the method on that variable. So I believe it is possible. I've done some preliminary research on that, and it had some interesting results. So I haven't quite, either I'm not intelligent enough to know what it's telling me, or it's giving me inconsistent results, one of the two. So I need to circle back with the Microsoft guys and say, hey, this is what I'm trying to do. Am I going about this the right way? Or am I, is the tool kind of messed up? I'm not quite sure yet, so I can't really speak too much further about it. But I did find 54 valid issues versus the 5 that we found with cat.net and FXCOP. So I will say massive improvement. Most of my false positives are on unvalidated redirects because it's passing a request parameter into a static string on the front end, and I know all the static analysis tools get that one wrong anyway, so I don't feel that bad about it. Future enhancements, you mentioned the one, data flow. Now, I write code a certain way, and I'm running rules against the way that I write code. There are going to be 1,000 edge cases on these rules that probably will crop up over time. So right now I've got a support email address, so I'm encouraging people from the website to at least submit code examples and things like that so we can start getting them documented. Additional rules, obviously, on the top of my list right now, there's about 10 or 12 crypto no-nos I want to put a rule in for. I'd also like to just get a secrets analyzer put in place to start flagging bad S3 keys, passwords, crypto keys, all those types of things being placed in source code or config files, lots of XML processing rules that I'd like to set up. So this will be a never-ending, ongoing kind of fun project for me and some of my guys that are helping me out with it. You mentioned data flow analysis. The other cool thing I haven't gotten to yet is suggested code fixes. You can write a code fix counterpart to a rule, and when Visual Studio gives you that little yellow drop down, it gives you some information. You can code out a suggested code fix, and they can just click the button, and it will automatically wrap that database value with the anti-XSS.html and code method for them. Now that would be pretty slick. So that's something that I would like to get to down the road. It's not there right now, but hopefully at some point I'll be able to get around to that, at least in some cases. Now we can't auto-write all of the rule code for the dev teams. We're unfortunately, we still have to use our brains a little bit here, but we can at least make some suggestions in some cases. Acknowledgements. Eric Mead is one of my old college buddies that works with me at Cypress. He has done a ton of the heavy lifting on the rule side. He's writing rules faster than I can actually get them documented in the website. So, as I said, it takes twice as long for me to write that up. And obviously, if you see typos and stuff on the website, know that I wrote most of that between the hours of midnight and 3 a.m. in Norway last week. So, give me a break on that, at least for now. Tom and Manish over at Microsoft are the two main guys from the Git repo that helped me with the additional files problem. So shout out to them. And is anyone on Gitter? I don't write code enough anymore to actually to know that that existed. They told me that GitHub has an actual chat channel for a project. You can jump on Gitter and join the Roslyn channel, and the Roslyn developers that are writing this API are on this little chat room all day, every day, and you can just ask them questions and get feedback on things. So there's been a lot of anonymous input from just folks on there that I've never met. So it's another great resource as you're digging into this, trying to learn these things and get this stuff figured out. Pretty exciting, right? Okay, that is all the slides I have. We're down to 2 or 3 minutes left, so I won't hold you hostage. My email address, ejohnson@sans.org, is on here. Twitter handle @emjohn20. I do respond somewhat on Twitter. You'll probably get some pictures of my dog and my kids on there too if you follow me, so apologize for that if you don't like dogs or kids. So since we don't really have time for questions, I'm heading out to the Sans booth, which is just right outside the hallway, and I'll be there all day. So if you have questions, you want to chat more about this, just find me at the Sans booth. I'll be there pretty much right now. So we'll tie this off here. Enjoy the rest of the conference and come find me and say, hey,